I received 2 phones from a subscriber. One of them is still brand new and unopened. It's an iPhone 16 Plus 128 gigabytes that will be upgraded to 512 gigabytes. The other one is a blue iPhone 17 Pro Max. It will be upgraded to 2 terabytes. Its original storage is 512 gigabytes. Many of you know that we've previously upgraded a 128 gigabytes model to 2 terabytes, right? But upgrading a 512 gigabytes model to 2 terabytes is a first for us. So what's different? When you buy an iPhone 17 Pro Max in 128 gigabytes, 512 gigabytes, 1 terabyte, or even 2 terabytes, besides the storage capacity, what else is different? Today, using this 512 gigabytes to 2 terabytes upgrade, I'll show you that the different storage versions of the iPhone 17 Pro Max actually hide some surprising differences. The iPhone 17 Pro series is opened from the display side. Let's remove the screen and take a look inside. If you've watched my previous videos, you already know that from the iPhone 4 all the way to the iPhone 16 Pro Max, regardless of which storage version you bought, the only difference was the storage capacity. Everything else was identical. But starting with the iPhone 17 Pro, that rule has been completely broken. After removing the display, there's a large shield covering the bottom section. We'll remove all the screws around it. Then we can lift off the shield. The battery is attached to the back of this shield. Now let's look inside the housing. The iPhone 17 Pro motherboard is mounted horizontally at the top, instead of vertically along the side. To remove the motherboard, we need to remove every retaining screw. Disconnect every flex cable, remove both the rear cameras, the front camera, and the earpiece assembly. As you can see, the rear camera module takes up a huge amount of space. We'll protect both the camera and its mounting area. Next, we'll remove the front camera and the earpiece assembly. The reason we remove all these components is to access the 2 flex cables beneath the motherboard. After disconnecting them, we can lift the motherboard. There's also a wireless charging flex cable connected on the back. We carefully disconnect it and finally remove the motherboard. Take a look. The iPhone 17 Pro motherboard is incredibly small and compact. Let's peel off the protective sticker covering the storage chip. Now we can see the NAND chip. It's marked with K8A, beginning with an 8. If you've watched my previous videos, you probably already know which manufacturer made it. Next, we'll remove all the protective tape and foam padding from around the storage chip. Then we'll use copper foil to protect all the nearby components. Why? Because we're about to grind away the original chip. We'll secure the motherboard inside a precision grinding fixture, then select the iPhone 17 Pro Max NAND dual-layer grinding program. The grinding machine automatically locates the chip. After positioning, it performs a rough grinding pass, followed by a fine grinding pass, until every solder pad is exposed. After grinding, we remove the motherboard and inspect it. For safety, a small border is intentionally left around the chip area. Next, we prepare the solder pads. We apply flux, drag solder across every pad, level all the solder, and finally remove the remaining border completely. After cleaning everything, it's time for today's star, the 2 terabytes NAND chip. As you can see, the 2 terabytes chip is much thicker, more than twice as thick as the standard 128 gigabytes and 512 gigabytes chips. Next, we rip all the corners of the 2 terabytes chip, apply solder paste, clean it, and melt every solder ball into place. Do you remember what I mentioned earlier? Besides storage size, what else is different between the 128 gigabytes, 512 gigabytes, 1 terabyte, and 2 terabytes models? Here's the answer. If you're upgrading a 128 gigabytes phone to 2 terabytes, the chip required is different from the one used to upgrade a 512 gigabytes phone to 2 terabytes. What's different? Why are they different? Besides capacity, what else changes? I'll explain in a moment. Now let's install the 2 terabytes chip. Gently press it into place. When it has a soft, springy feel, it's perfectly seated. As you can see, the 2 terabytes chip is not only thicker, it's also physically larger than both the 128 gigabytes and 512 gigabytes versions. After installation, we clean everything thoroughly and replace all the foam padding with brand new pieces. Finally, remove the protective film from the foam pads. Clean everything once again. Now we reinstall the motherboard. First, reconnect the wireless charging cable. We try to keep every step as clean as possible. Now back to the earlier question. Besides capacity, what else is different between the 128 gigabytes, 512 gigabytes, 1 terabyte, and 2 terabytes versions? Here's the secret. The 128 gigabytes model uses a slower NAND chip. The 512 gigabytes and larger models use high-speed NAND chips. That's why when upgrading a 128 gigabytes phone to 2 terabytes, you must use the matching S5 low-speed NAND. But upgrading a 512 gigabytes phone to 2 terabytes requires the matching S60 high-speed NAND with the same underlying architecture. That also means a high-speed NAND cannot simply be installed onto a 128GB motherboard. Technically, it can be done by separating the motherboard layers and modifying internal traces. But the cost is extremely high. Most customers wouldn't accept that level of work just for a storage upgrade. After watching today's video, you should now understand that when choosing between the 128GB and 512GB iPhone 17 Pro Max, there are differences beyond storage capacity. Do you think Apple did this intentionally, or is there another reason? Also, without opening the phone, how can you tell whether your NAND is a low-speed or high-speed version? I'll show you at the end of the video. Next, we clean away all the old adhesive from both the housing and the display. Install a new waterproof adhesive, reconnect the battery. Continue cleaning everything carefully. Remove the final protective layer from the waterproof adhesive. Take off the camera protection cover. Clean everything thoroughly, then close the display. Place the phone into the heated pressure machine to ensure the display adhesive bonds perfectly to the frame. After pressing, install the two bottom screws, connect the phone to the computer. The phone enters DFU recovery mode. Reinstall the latest iOS version. If the wrong NAND chip has been installed, the restore process will fail at around 18%. One important note, after every storage upgrade, the iPhone must be restored. Apple only allows installation of the latest iOS version. There is no option to install an older version. After installation completes, the phone restarts to the activation screen. Reconnect to Wi-Fi. Activate the phone, and finally reach the welcome screen. Tap Get Started, open About, Success. We have successfully upgraded an iPhone 17 Pro Max from 512GB to 2 TB.